Okay, this is 5.4, the second video. We're still solving trig equations with unlike terms. This time we're going to be using reciprocal identities. Identities. How about spelling it right, Bentley? Okay. You should already know these reciprocal identities. Again, they started with us in the first unit. Two reciprocal identities are sine theta, and its reciprocal identity is cosecant theta. Cosine theta, its reciprocal identity is secant theta, and tangent theta has a reciprocal identity of cotangent theta. So if that's the case, then cosecant theta could be written as 1 over sine theta. Secant theta could be written as 1 over cosine theta. And cotangent theta could be written as 1 over tangent theta. Those are all reciprocals. And so that's what we're going to use in order to solve the equations that we have. Now you're going to need to know, when will I use reciprocal identities instead of Pythagorean identities? Well, one of the first things you'll notice is you will have equations that actually do have reciprocal identities within the equation. So here's an example of one of those. Tan theta minus cotangent theta minus 3 equals 0. Tangent theta, cotangent theta are reciprocal identities. Another thing you should notice is you don't have any squared terms. So I cannot use Pythagorean identities unless something is squared already at the start. I also should notice I don't have a GCF. Without a GCF, I cannot factor anything out to start with. So I'm going to need to use the Pythagorean the reciprocal substitution. So in order to know which one am I going to substitute in for, I'm going to substitute in for the one that's not on the calculator. That happens to be the cotangent. So I'm going to substitute in its reciprocal so that I have a common term, and I'm going to make this 1 over tangent theta minus 3 equals 0. In order to get the tangent theta out of the denominator, I've got to multiply through by that trig function. So I'm going to multiply through by tangent theta. And I'm going to distribute it to the entire equation. Tangent theta times tangent theta is tan squared theta. Tangent theta times negative 1 over tangent theta is just negative 1. Tangent theta times negative 3 is negative 3 tan theta. That's equal to 0. Next step should be to reorder the equation and put it in descending order. So tan squared theta minus 3 tan theta minus 1 equals 0. Well, because I'm pretty adept at working through these, I can look at that and I recognize this is not a factorable quadratic. And so my next option is simply I'm going to need to use the quadratic formula. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So for this equation, my a is 1, b is -3 and C is -1. I'm going to substitute those in order to find these angles. So the opposite of B is +3 plus or minus the square root of B squared, so 9 minus 4 times 1 times -1, all over 2a. 2 times 1 is 2. So theta equals 3 plus square root. I'm going to figure that out. So -4 times 1 times -1 is +4, and 9 plus 4 is 13. Next thing I'm going to do after I've gotten this far is go back and find out what is the tan of theta for that value. And so really it's tan inverse of 3 plus the square root of 13 over 2 and tan inverse of 3 minus the square root of 13 over 2. So let me get my calculator, see what angles I get. Going to need to use some parentheses most likely, or if you've got my calculator I could enter it in as a fraction. I'm going to probably go about this the long way. If you know how to do it a little bit quicker, that's great. So I'm just going to go on and figure out what does this fraction come out to be equal to. So 3 plus the square root of 13 divided by 2 is equal to 3.3. Then I'm going to find the angle, so second tan, second answer, and my calculator is in radians. So in radians I got 1.277. In order to find my second radian measure, I've got to add to that 3.14 or pi. So on my calculator I'm just going to go plus pi, and I get 4.418. That's radian measures. We'll go back and find the degrees here in a second. Then I'm going to do the same thing, but I'm going to do 3 minus. So 3 minus square root of 13 divided by 2, negative 0.3027, second tan, second answer to get my first angle. And my first angle I got negative 0.294. I will not have a negative angle. We're going to keep it as a positive. So I'm going to add to that 2 pi to get the first one. So I've got 5.989. And if I want to find the one that is on the other diagonal quadrant, I'm going to subtract just pi from that. And I get 2.848, rounded 3 places. Those are in radians. So I either could go back and go through this again, but this time change the mode on my calculator into degrees like this, or I could just multiply each of those by 180 over pi, because that's the conversion factor to go from radians into degrees. Doesn't matter which you do, either one will work. So if I multiply this times 180 over pi, 2 degrees, to change 2 degrees, let's see what we get. 2.848 times 180 divided by pi This angle is 163.2 degrees. Then I'm going to find this one. So what am I going to do? The easiest thing to do would be plus 180. And you get 343.2 degrees. Well, 5.98 is really close to 2 pi, or 6.28. And 343.2 degrees is pretty close to 360 degrees. So it looks like those conversions were correct. We can go back and convert either one of those two. So 1.277 times 180 divided by pi gives an angle of 73.2 degrees. Easiest thing to do would be to add 180, and we get 253.2 degrees. 1.277 is in quadrant 1, because in quadrant 1 we go for radian measure from 0 to pi over 2, and pi over 2 is half of 3.14, which is 1.57. So that's pretty close to 1.57. 73.2 degrees, pretty close to 90. Let's look at one more example. Let's take the equation two cosine theta minus 3 secant theta equals 5. I just made that up. Don't even know for sure that it's going to work, but we're going to give it a try. First thing is, set the equation equal to 0. So 2 cosine theta minus 3 secant theta minus 5 equals 0. Next, I've got cosine and secant, which are reciprocals, thank goodness. No squareds in it, no GCF in it. So I know I'm going to use the reciprocal identity with cosine to secant, and I need to change secant into 1 over cosine. So 2 cosine theta minus 3 over cosine theta. It's 3 times 1 over cosine theta. That's the same as 3 over cosine theta. Minus 5 equals 0. I will distribute through by this denominator that I don't want, which is cosine theta. So cosine theta times 2 cosine theta is 2 cosine squared theta. Cosine theta times negative 3 over cosine theta is simply negative 3. And cosine theta times negative 5 is negative 5 cosine theta equal to 0. I need to reorder that, so that becomes 2 cosine squared theta minus 5 cosine theta minus 3. I'm pretty adept at factoring, but I would probably have to try this out just to prove that it didn't work. Looks like with a 2 and a 3 and a 5 it could work. So I'm going to try it, see if it works. 2 cosine theta times cosine theta. That's 2 cosine times cosine is 2 cosine squared. This would have to be a 3 and a 1. I know my signs are going to be different, so I'm going to try the 3 here and the 1 here. Let's check my smileys. It gives me 1 cosine theta. This one gives me 6 cosine theta. Now, I'm not going to add those together to get the middle term because that's a negative. I'm going to subtract them. And 6 minus 1 will give me 5. I need a negative 5. So the 6 has to be negative, which means 2 times negative 3. And this is a positive 1. I just pretty much lucked into this being factorable because, like I said, I just made it up as we went. Set each of my factors equal to 0. This one over here on the left becomes cosine theta equals negative 1 over 2 because I subtracted 1 from both sides and then I had to divide by the 2. And I should know this from the circle, but if you don't, no biggie. We'll type it in our calculator. We're going to do the inverse of cosine of negative 0.5. I've got my calculator now in degree mode, so I can just go second cosine negative 0.5. I get 120 degrees. I'm going to look over here at my circle just to think this out loud. So I've got a negative 1/2 right here on the x-axis. That gave me my 120 degree angle. Oops. There again, I got off the page. Trying to move everything. There we go. So I've drawn my circle. I looked at negative 1/2 on the x-axis right about there. First angle it gave me was 120 degrees. I go across the x-axis, so my next angle has to be down here. If it went 120 degrees that direction, then this direction is also 120 degrees. And so all I need to do is subtract this 360 minus 120, and it's going to give me 240 degrees. If I need it in radians, but I forgot to change my calculator, there's the simple conversion. You could multiply, if you want to change it to radians, times pi over 180. That'll give you the decimal form of it. 120 and 240 are actually on the unit circle, so you could just happen to know that that's 2 pi over 3 and this one is 4 pi over 3. When it says radians, it really doesn't have to be in this form unless you're looking at multiple choice answers. Decimals, perfectly okay for those. Let's look at this one. I need to solve this for cosine theta. Add 3 to both sides equals 3. If we were going to type this in the calculator, we're going to get error. Why are we getting error? Cosine can be no more than 1, no less than negative 1. This side has no solutions. These are our only two solutions. Carry on.